Hello there, my name is Owen Cooper from Ormiston Venture Academy, and I teach in the computer science department. And this is a little video we put together for the Year 10 Parents Evening, just to give you some idea of what we're doing and what the students are doing in Year 10 and what they're about to do, and how we can help perhaps out with some of the information for Parents Evening, just to give you that brief introduction to that. Now, what I'm going to do is I'm going to share, hopefully, if technology allows me, share a presentation, and hopefully you can see that on your screen in just a second here. And what this will do is allow me just to have a little chat with you about what we've been doing in computer science up to now in Year 10 and what we're currently and moving on to doing. So myself and Mr. Richards, there's two teachers within Year 10 for computer science, and obviously we'll have one of either of us. And we're both following the same curriculum, because obviously all Year 10 students in computer science need to follow the same thing. And what we've done, we started this year with the hardware element of computer science. Now, computer science is split for our exam board, which is the OCR computer science. Computer science is split into two components: component one, component two. Component one is the hardware, the software, the networks, how the computer works, binary, all of the mainly the sort of internal parts of a computer, and that sort of physical element to computer science. Component two is the more of the programming, the algorithms, the programming software, programming computers to do things. And traditionally, that's normally been the harder of the two components. However, what we're trying to do this year is to put a little bit more emphasis again on that, and to focus a little bit more on some of the programming constructs and the knowledge of programming, to then develop that ready for throughout the year and ready for the GCSE exams next year. You can see on the screens, hopefully, that you can see at the bottom where we start with hardware and software, and that works through CPUs, RAM and ROMs, secondary storage, operating systems, utility software, and some application and simulation software, all of which we've gone through. We have been through all of these topics actually over the last 3 and a bit years of computer science here at the Academy. So these are not new topics. We are just sort of building on top of these topics, really, just to extend that knowledge a bit further, to go for those higher levels, and to put a little bit more sort of meat on the bones, if you like, of that, in that terminology. Then we've just finished, at the time of recording this video, we've just finished and just completed the assessment actually for networks. And that was a tough unit. There's a lot of information to put across for that. There's a lot of knowledge and a lot of knowledge recall that we need to do. So we've done a lot of memorization in those. But you can see there some of the topics that we've gone through with the network types and the topologies and the hardware and various different elements like that. Now, all of the computer science students have just finished the network assessment. Ordinarily, what would happen is when they come to do their OCR GCSE in just over a year's time now, what will happen is, like I said to you before, it's split into two components, component one and component two, but each component will be broken down into subcomponents within that computer exam. Each exam is an hour and a half, and each exam is out of 80 marks. So what then happens is there will be a little bit of, in component one, for example, there'll be a little bit of networks, there'll be a little bit of hardware and software, there'll be a little bit of data representation and so on. And then for component two, there'll be a little bit of algorithms, there'll be programming constructs, programming knowledge, there'll be a little bit of things like Python programming, things like that. So it breaks it down into smaller chunks. So this is, like I said, this is what we've been doing since September up till now. What we're looking at moving on to is now data representation. So that's what we're looking at now. This is a particular topic that we cover quite a lot in computer science, because it is the very basics of computing. A computer and the digital representation of that computer will only understand binary. That's that ones and zeros. And that's why we keep repeating this, because it's quite a biggish topic, and there's quite a few marks to be gained in the exam based on this particular unit. Data representation doesn't just cover binary, though. It covers various different elements, from encryption to compression to sound to image representation. And that's something that we work on and will be working on this particular term. Like I said, hopefully the binary element we will go through, and we will sort of just do a bit of knowledge recall from previous years on that. So hopefully it won't take us too long to do that. But again, we can then start to move on and start to look in more detail at the sound and image representation. And you can see there from the encryption and the binary shift and addition. Then we're going to move on to the algorithms. So that algorithms element is mainly component 2, which is the paper 2 that I was talking about earlier, where we start to look at something called computational thinking. And that's where we start to try and understand how a computer works and thinks, and how we can program that computer, and how we can make software work and run as a logical computer. And we use something called abstraction and decomposition, and that's where we can then start to look at a problem, and that's where the algorithm turn comes in. We look at a problem and we break that down into manageable smaller chunks. There's the decomposition. We take out all of the information that we don't necessarily need, which is the abstraction, and we are then left with the key information that we can then use to create a program, write a program to a given scenario. Now, for the computer science, for OCR, we don't have to do a giant, great big programming project like we used to have to do. We can now do smaller, bite-sized little chunks of programming that we've been doing over a small amount of time. In year 9, we did a bit then, and that we will be doing for the year 10, where we do little bits of skills and knowledge that students will then be able to do, and then apply, as it says there, apply that knowledge to programming projects. It says leading up to programming projects in the summer term. Ultimately, what that will be is students will be given a range of different projects and targets to complete for programming, and then they'll use all of those skills that we've learned, all of those little bits of knowledge that we've learned, whether it's searching, whether it's sorting, whether it's using things, arrays or lists or things like that, and to then be able to complete and finish those little mini projects. The good thing we love about OCR is that it's not one big giant project like we used to have previous in a couple of years ago. It is now little tiny projects that we can then start to build up students' knowledge on, which is excellent. Looking at then ways to help at home. I hate the cliche, but the vitals, the venture vitals are vital. They are very important. They are, if you haven't seen them, I'm sure you have, but they are the paper-based venture vitals with all the departments' knowledge organisers in, things that are key to that department area. We have a focus on, which is like a particular element that we look for extended learning, that I know Mr. Riches has been putting on for students to access. But also we use those knowledge organisers to help us revise and to help us look back at some of those knowledge and perhaps some of the gaps that we might think, oh, well, what's the term algorithm? What do I mean by that? How do we look at that? Where can I look for some assistance on that? I'll have a look at the Venture Vitals, or I'll have a look at the knowledge organisers. Now, the knowledge organisers, there are electronic versions of the knowledge organisers. They are all on the Google Classroom for Year 10. They're accessible. You can access them from home. That's if you've got an internet access, you can access that from home. They are accessible within the academy, obviously on the computer desktops. There is a Craig and Dave YouTube channel, which is really, really good. They actually link really well. We've got something called learning menus, which is a way of accessing revision materials, videos similar to Craig and Dave. And then what that does is then give the students a set of tasks. Some are short things like gap fill tasks. Another good thing with OCR is that they're not all long, really 8, 10, 12 mark questions. There's a few 8 mark questions in each exam paper, but there's some multiple choice, there's some gap fill, there'll be some link words, etc., matching words and things like that. So these learning menus are really, really good. Again, they can be found on Google Classroom. And another area that I'd like to mention is Seneca. Seneca is a really, really good revision tool. It's an online learning revision tool where students can access. We can then set up misconceptions assignments, let's say, where students are perhaps struggling a little bit on, and we'll do that linked on perhaps like we did currently with the networking. We'll see any misconceptions in the assessments that we've done, and then we can set up mini assignments, if you like, for students to do at home for revision. So that's ultimately me done. I'm just going to go back onto here because I know sometimes it's difficult to see, and I'll just stop sharing that. Hopefully you'll see that now and you can see my screen. And what I will do then is I will just say that if you need to contact either myself or Mr. Riches, that is fine. We obviously look forward to speaking to you on Parents' Evening. And it's always great to speak to parents and have that more in-depth conversation, even if they are short time spans. But if you do want to speak to us, by all means, you can drop us an email. My email address is ocooper@ormistonventureacademy.co.uk, and Mr. Riches is lriches@ormistonventureacademy.co.uk. So it's really, really good to speak to you. If you need any more clarification, then please do drop us an email or give us a ring at the Academy, and we will speak to you soon. Take care. Bye-bye.